Hello everyone, it's December the 1st. Alright, so the goal is challenge, and we're gonna do this problem using a different method. Actually, I've thought about a method last night when I was sleeping, so we're gonna try that. Alright, let's do this one first. If two strings are close, okay, two strings are considered close if you can attain one from the other using the following operation. Swap any two existing characters. Transform every occurrence of one existing character into another existing character, and do the same with the other character. For example, turn A into B's and all B's into A's. So you can use the operations on either string as many times as possible. Given two string, return true if the two are close, false otherwise. Every occurrence of one existing character into another existing character, and do the same with the, yeah, so we just completely flip. So either flip them, any two existing. So swap two, but you can do this as many times as you want. Or, but can I do, wait, hold on. Alright, back. Just handle the cat's needs. Alright, we're saying we can use the operations on using the following operations. I can use any operations. Yeah, I think you can use any operation. I want to know if it's possible to turn one to the other. So ABC and BCA. Operation 1. I mean, because you say you want to swap any two. So if word 1 and word 2 are anagram of themselves, I think it will always be possible, right? If they are anagram. And then I can always swap this, right? Swap this, swap. Yeah, if they're anagram, then it's definitely true. So ABC and BCA definitely work. In fact, any anagram will work. And they have to have the same number of letters. So example 2 shows you that. Example 3, now they are not anagram. So I think the goal is to turn the two words using operation 2 to turn them into anagram. And then we can use operation 1 to turn them the same. That's 3, right? If you think about it. Operation 2, so I have a word 1 is CABBBA. Another one is ABBCCC, right? So I have BBB on one, CCC on the other. So I can say I want to do operation 2 because I want to swap them. Yeah, I say I want to turn the ones, I want to make them into anagrams, okay? So all the B's need to turn into C, and all the C's need to turn into B. So this will become BACCCA. So we have CCC, right? And we have BAA and ABB. So we just swap again. So 2 operation 2. Now it would be ABCCC and then B. And then it become anagram, so we can do it. So yeah, so just a matter of using operation 2 to convert. And how do we do that? Well, I mean, when you pick another one and you do this swap, I mean, we can, let's make word 2 as a template. And then in word 2, we can have a counter, right? That's how we do anagram as well. So we have a counter. We have, A is however many, B is however many, C is however many. And then we go to the other word, right? Because we have to, if they're not anagrams, then we need to match. So they must have, the count need to match, right? The count need to match. If the count doesn't match, then it's not gonna do. And if the count matches, right? It doesn't really matter what matches what, right? It doesn't really matter. Oh, it does matter, because when you do the operation 2, you can only use existing character. So if the 2 have different characters, that's gonna be your trouble. Which means what we can do is we can I'd like to say set them, but I think there are better ways to do it. Yeah, we're gonna counter them and then just see if the 2 contains the same character. Okay? Yeah, length is the first. Length is the same, check the character. Character has to be the same. And then the third one, now if the characters are the same, so the 2 has exactly the same character but with different counts. If the counts are the same, then we're done. But if they have different counts, right? If they have different counts, then we need to swap. Okay, so when we swap, basically we're just moving the keys that swap, right? So we're moving the keys. If at the counter, right, I have the value, so we're just moving the keys. And when we move the keys, we just swap the keys, right? And as long as the count matches, so we can always, right? Like if it's not, we can always swap there, and then we need to swap this. Yes, we can always make it work. So it boils down to check on the numbers, number of repeats on each letter. So it looks complicated, but essentially it's not. Okay. Yeah, just spend some time watching the exposition of Liver King. That thing is interesting, honestly. Dude is very dedicated to build his brand. All right, I think it's August. His goal is in August 2021. He said, "I will make 1 million. I'll create 1 million follower by March 2022," and he did it. And it made gigantic amount of money out of it. It's a fraud, but on the other hand, you have to admire, right, the dedication that he put into this. Jeez. At what cost, though? I mean, You fake it for however long you can fake it. I mean, for him, it doesn't even fake it that long. It's only like a year, right? But man, it's only like a year, a little bit over a year. Even if he can make $100 million a year, is it worth it? I mean, he's trying to get this one churning for a couple years, and then, I mean, who cares if you get caught, right? Because you already earn your money. That's the end of it. The end stage of capitalism. That's all I've been seeing these days. All the articles I read, the things I watch, is the end stage, which is basically the pursuit of capital, of money at all cost. There's no moral, there's no morality, there's nothing. All right, everything is just for the money. The last stand before everything crumbles down. Damn. All right, anyway, let's handle this. So this is our first thing, and then we need to see C1. Okay, is counter word 1. Yeah, let's be cheeky. Do this. Okay. Now we need to see. We need to first check if the keys are all the same. But of course we can say if len C1 is not equal to len C2, that's also false, right? Which means some of them contain the letters and not occurring in the other. And then we need to check one by one, we need to check, right? One by one we need to check. How do we check? Actually it will be easier. We can just say sorted C1 if it's not equal to sorted C2. Exactly, that's checked everything. And then if sorted C1.values is not equal to sorted C2.values. You know what? Let's make it explicit. Or this return false. Otherwise, we'll return true. All right, this is my understanding of this problem. One, two. Okay. You wanna do it? Yeah, let's do it. There we go. Okay, what method did I use in the past? Curious. I'm still coughing. This thing just been lingering for almost 2 weeks. This starting getting worse and worse. And word 1. So operation 1 indicates that if word 1 and word 2 are anagrams, they can be converted. Operation 2 indicates that if word 1 and word 2 share the same letters and the same pattern in count for all the letters, they can be converted into anagrams. Thus, the check is for the 2 words to have the same length share the same letters and have the same pattern on letter count. Well, we call it ON. That's ON. This sorting thing is O26 log 26, so I'm not gonna count it. All right, so, but it was slower. That's something I want to see. 128. Counter of counter. Maybe it's faster than sort. Keys equal to keys. Really, you can do keys comparison directly. What? Holy crap. Counter, you can do keys comparison. Hold on. Can you do that? I am not sure, actually. It's not this. Rich comparison, okay. Well, that's countered directly. That piqued my interest. A.keys. Holy crap. Wow, so we can simplify it. So the keys, I don't have the sort. We don't have to do this because this value will not be okay. Then we just need to return this equals this, and this equals this. Dict keys can be compared directly, and the length check can be accomplished using the value, the counter value check. Okay. But a sort is still gonna be, we go faster. Much faster. 144, 152, so we got more. Ah, well. What was the original solution? Damn. I have no idea what I was trying to do. Anyway, okay, we're done with this. Let's go back to this one. So I don't have to do bisect. That's what I realized. I can just use counter. That's what I realized. But the basic idea is the same, right? So here's what we're gonna do. So same idea as solution 2, but we don't have to use binary search to find, right, to find the count. We can use counter directly. Right, so we do this, we do everything that's as it should, right? We do the pre-sum, yeah, which is fine. And then, don't do this. We have the index. So what I can do is the left. We're gonna say left counter should be the counter pre-sum, right? Pre-sum all the way to index. And then right counter is gonna be the counter pre-sum index plus 1, because we don't want index in it. Right, and then we're gonna say handle array starting from the beginning. Then it's basically just should be right counter, right? Right counter 0 plus right counter 1 and plus this and plus and plus this. Okay, that's the start. Right, so once you say handle subarrays that cross k, including starting with k. Now we're gonna have to go left. Okay, so we say LC. Then we say rest plus equal to v, right? Because it's on the left side, however many we have, times RCK. Okay, this is odd length. V times RC K plus 1. That is going to be even length. So we don't need any of these. All right. And then we have the last one is ending in K. Well, it's ending in K, which means it's the left pre-sum plus equal to this plus LC minus 1. Okay. Yep. Much simpler, right? I don't even need this. There's no indices. Oh. Oh, we still on. I pressed the wrong button earlier. I pressed, should be Command Tab. I pressed Command Q. Jeez. All right. Try this one. There we go. That's what I'm talking about. That is what I'm talking about. Come on. This is the one. This is the one. Oof. Yeah. I don't know why I hadn't thought about using counter directly. I mean, this is not the first time that I have used binary search for a problem that can be easily solved using counter. But anyway, using this, so when and that's straightforward. Yeah, there's no, I didn't even sort. I mean, why do you say O and log n? That's not O and log n. I didn't sort. Oh, I have bisect. That's why. Yeah, but here's no bisect. Everything is as straightforward as it can be. You know what? I think this is better. No, I think this is better. And do you think it'll be better if we include index in this? What if we include, then we include it into the RC, okay? And then we need to do the crossing. With the left and on the right. Let me see. Yeah, you know what? Actually, what if I do this? You know. Then we don't have to handle this because ending in K has already been considered. Starting and ending with K. All right. Hold on. Wow. Things just keep breaking these days. Okay. What if I do accumulate Okay. And then so add 1 have to index plus 1. And then I don't have to do this. What do you think? I think it's awesome. Yeah. Counter of pre-sum to the left of k, and counter of pre-sum to the right of k, including k. Note that pre-sum has a 0 at the beginning. Yep. That's it. Yeah, we add this 0, now we can handle everything. Oh, there's just 0, and then we just find the k, the value on the right. And it includes, right, it includes everything. Good. Okay, so we're done with this. That's a very good one. I'll put it there. It took me a long time to solve. Okay, back to contest. Oh, I didn't tell you which one you done. Shoot. How am I supposed to know? Wow, look at this. I did it bi-weekly, but they're terrible. All right, so I won't be able to know. Oh, I will know if. Yeah. So we don't have to do the virtual. All we need to do is just do the problem, right? We can just pull it out. True. What day? Yeah, the passing, there's a lot of people passing this one. All right. Okay. Minimum cuts to divide a circle. So either cross 2 on the edge and across the center, or a 1 on the edge and a 1 on the center. That's the invalid cut. Given integer n, return the minimum number of cuts needed to divide a circle into n equal slices. N is 4, then we need 2. Yeah. N is 3, we need to do this. Well, wait, is that equal parts? Equal slices. So I think if it's because 1 divided by 2, it can do 2, right? And hold on, can we have a situation like, I don't know. I don't think so. Yeah, if we do another one, that's 8. Well, hold on, actually, no. Six doesn't work because these two are not the same. So it has to be 8. We do 1, 2, 3, 4. 4 cuts. Right, 4 cut to get it 8. So 1 cut, get a 2, 2 cut, get a 4. There's no 3 cuts. 3 like across the center. That doesn't work. It has to be 4 cut. 4 cut would get 8. So instead of multiply by 2, and we can now do 5 cut, right? So the next one has to be 8 cut. So we do 5, 6, 7. It has to be 8 cut. We'll give you 16. So that's kind of that. Otherwise, we have to use this. I mean, we can always divide. Anything we can divide. Like, let's say we get a 5, so we can divide it by 5, right? Get a 6, we can divide it by 6. So basically, if n is power of 2, right? If n is power of 2, then we can do that. Otherwise, we don't do. So basically, the question is, how do we tell if n is power of 2? Well, we tell that if n is power of 2 by using a mask, right? By using a mask. So, yeah, I don't think we should do the virtual content. Just do it this way. It's easier. And it's more fun, actually. So the mask, because the largest n is 100. So we can do if n mask what's the mask for 100? For 100, 128, right? Because 16 32 64 64. 32 is 1, 0. So it's 1, 1, 0, 1, 0. Right, 5. No, that's 4. That's 2. Jesus, come on. And then 64. And then 128. So 1, left shift. How many? 5, 6, 7. Okay, so it's a 1, left shift 7, minus 1. So if this is equal to 0, then we return n divided by 2. Else return n. Something like this. Kind of don't want to test. I just throw it there. Actually, I'm not that confident, but we're gonna try. Oh no. Oh, I think I misunderstood the problem completely. Wait, hold on, what? Oh, 1 should be 0. 2 should be 1. 3 is 3, 4, 5. I'll just do this. Wait, hold on. Okay, yeah. Oh. Yeah, that's not right. Gosh. Gosh. Then how do I tell? I mean, but it's not right anyway. I mean, I can list all those values out, but I just noticed that if we do 100, the answer is 50. How is that 50? I don't understand. Why 100 is 50? No, let's get another example. I mean, this is not right. But 1, 2, 4, 8, 16, 32, 64. That's my understanding at the moment. Three cut to make 6. That's the thing I don't understand. And equal slices. How do you do 3 cuts? I mean, 3 cuts. Then what? So what I observe is even numbers divide by 2. But why? Okay. How would you do 3 cut? Oh, damn. Dude. I don't know what you're doing, man. That's 3. Dude. The hell? What the hell? Oh. Seriously, what the hell? I realize when I do this. One should be no cut. Man, another check at the beginning. Yeah, I don't know. This was actually poor performance. I got stuck. Didn't realize when you make a long cut, they don't have to be perpendicular. Shake my head. Also, n equal 1 is an edge case. Fooled me. Alright, yeah, I don't want to do it anymore. Let's call it. Let's call it a day. But dude, isn't this problem just fooled you, right? Jesus. Alright,